Covalent bonding. Covalent bonding is a type of bonding that occurs between two or more non-metals. This is different to ionic bonding, which requires a metal and a non-metal. So, chlorine is a non-metal. Here we have a chlorine atom. The atom has an incomplete outer shell, which means it's going to be reactive. Now, we saw in ionic bonding that one way to fix this problem was to get a metal, for example sodium. Sodium would lose an electron and chlorine would gain this electron. Then we would produce two ions, both of them having a complete outer shell. However, what if we don't have a metal? What if we have two non-metal chlorine atoms? Would it still be possible to have a full outer shell? The answer is yes, and it's to do with sharing electrons. Now, first of all, we're going to draw the outer shells only, because that's where most of the chemistry happens. Now, chlorine is in group 7, so it has 7 electrons in its outer shell. Next, we're going to draw the one on the left with crosses. This is important so that we know which atom the electrons are coming from when we draw our diagram. Now, the rule with covalent bonding is you get what you give. For example, we can see that this atom on the left has 7 electrons. It needs one more to have 8 electrons in its outer shell to complete it. Since it needs one more, it has to share one electron. And the same applies to the chlorine atom on the right. It has 7 electrons, needs one more, so must share one. So, the chlorine atoms come together and we get the following. So, let's count how many electrons each atom has now. Starting with the left. 1, 2, 3, 4, 5, 6, 7, and 8. And on the right, 1, 2, 3, 4, 5, 6, 7, and 8. So notice now that both atoms have 8 electrons. We now have a complete outer shell in both atoms, and we have now created a chlorine molecule. This shared pair of electrons is referred to as a covalent bond. And covalent bonds are strong. The reason for this is because the nucleus of an atom is positively charged. And these positive nuclei are attracted to the shared pair of electrons, meaning that these atoms are going to be held together tightly. We'll talk more about the properties of covalent molecules later on. For now, we're going to practice drawing some more molecules. Now, what we have here is a chlorine molecule, and this diagram is called a dot and cross diagram. However, we could also draw it as a displayed formula. So we have 2 chlorine atoms, and the line in the middle represents the covalent bond. One line for 2 electrons. Let's try another example. Let's see if we can draw oxygen. Remember, we're only drawing outer shells. So in O2, we're going to need 2 oxygen atoms. Now, how many electrons go on the outer shell of an oxygen atom? To know that, we have to look at the periodic table. These numbers are the group numbers, and they can tell you something very important. The group numbers tell you how many electrons are in the outer shell of an element. For example, oxygen is in group 6. That means it's going to have 6 electrons in its outer shell. So 6 here and 6 here. Again, notice that I've drawn them differently on purpose. So these atoms have an incomplete outer shell. They only have 6 electrons. And the rule with covalent bonding is that you get what you give, meaning this atom has 6 electrons, it needs 2 more to have 8 in its outer shell, and therefore it has to share 2. And the same applies to the one on the right. So they're going to come together and form a covalent bond. So let's count how many electrons each atom has. Starting with the left. 1, 2, 3, 4, 5, 6, 7, and 8. And on the right, 1, 2, 3, 4, 5, 6, 7, and 8. Perfect, so both of them have a complete outer shell, and we've created an oxygen molecule. This is the dot and cross diagram, and this is the displayed formula. Notice this time that we have 2 lines instead of 1. This is because there are 2 shared pairs of electrons, and each pair is represented by 1 line. Let's move on to one final example. We're going to draw ammonia. So looking at the periodic table, we can see that nitrogen is in group 5, so it's going to have 5 electrons in its outer shell. And as for hydrogen, it has 1 electron in its outer shell. Okay, let's draw ammonia. So we're going to have 1 nitrogen atom and 3 hydrogen atoms. Since nitrogen is in group 5, we're going to put 5 electrons in its outer shell. And hydrogen is going to have 1 electron in its outer shell. Okay, so how many will they share? Now hydrogen's electron is in the first shell. And remember, the first shell is the smallest. It can only hold a maximum of 2 electrons. Meaning that hydrogen already has 1 electron, so it needs 1 more to have 2 and have a full outer shell. So it has to share 1. Nitrogen, on the other hand, has 5. It needs 3 more to have 8, so it has to share 3. And it's going to look like this. So if we count, the hydrogen on the left has 1, 2, the hydrogen at the bottom has 1, 2, and the hydrogen on the right has 1, 2. So they all have 2 electrons, and therefore they have a full outer shell. As for nitrogen, it's going to have 1, 2, 3, 4, 5, 6, 7, and 8. Perfect. And here we have the molecular formula, the dot and cross diagram, and the displayed formula on the right. Hey guys, if that video helped you, support our channel by liking, subscribing, and sharing it with your friends. And more importantly, if you still have questions, drop a post on our forum at ExamQA.com, where I will personally be there to help answer your questions. Mohammed signing out.